I think of myself in general as nothing I do matters when I'm with the team. The only thing that matters is what they do differently once I leave. This story is not about that. This is a different story. Because, if you want the slides, they're here. I will show these at the end of the presentation as well. For me personally, I don't tend to care about this until I care about the presentation. But different people, different stuff. Okay, so I've been writing this book with Trisha Broderick. It's actually a book on speaking, so you can judge for yourself if I'm good at this. Trisha, like, books take forever to write. So like sometime in like, I don't know, maybe February, Trisha was like, oh, it looks like I'm getting a new job. And I was like, oh, congratulations. It didn't really affect the book at all, and I didn't really think of it too much more. But then about 3 months later, she was like, I think we could use your help. We used to have 3 programmers, and we're down to 1 programmer, and he's a junior programmer, and like, could you just help? And I was sort of like, that's not really what I do. But if you've ever met Trisha, you will know how hard it is to say no to her. So I found myself taking on this project. I do it about part-time, and I'm on week 5 of it. This talk is about the first 4 weeks. So the 1 programmer, that would be Jonathan. If you know anything about me, you know that I'm going to be pair programming with this person. So I've been pair programming with him about 4 hours a day. So interesting little story. When I'm a coach, I only work 2 hours a day with each team. And the reason for that is if I work more than 2 hours with a team, I burn them out and they do not want to see me again. And here Jonathan is getting me full force for 4 hours a day. We'll just go with he is tired. Their system is pretty simple, right? They have an ASP.NET app. It has a front end of Vue.js. It talks to the database through Entity Framework. And there is a single database that it talks to. They're the only consumer of that database, right? It's about 50,000 lines of code for this whole code base. It's not like a crazy big project, which is to be expected. There's sort of like 3 people built this over the course of like 5 to 10 years, something like that, I don't know. And then 2 of them, I think, sort of were like, I don't know how to get out of this mess, so they literally got out. And now we got Jonathan and me. There are 3 things that we have been using that really makes this successful. And I'm going to take you through this in 3 different pieces. But as long as we've got knowledge, tools, and feedback, I find AI is pretty good. We have a saying, the stupidest, fastest thing that will work. Right? So most of the time we are in Claude code on Sonnet 5 at low reasoning. And we do that because it gives us good feedback cycles. If I have these 3 things, stuff tends to work pretty well. If I can add into that small steps and focus, it really shines. You're going to see this pattern over and over as I go through this story. I'm going to talk about it as it relates to the database. I'm going to talk about it as it relates to our tests. And then I kind of need to talk about nullables because they enabled so much in a place that was so hard. So if you have any of these problems, like not telling you about this part is going to be a disservice. But let's start with the database. So over the course of 4 weeks, so 20 days, 20 half days, we have backups of production. And we reduced them by 90% of their size. We took almost like 40% of the tables in the database are gone. They're just not there anymore. We have updated the schema 25 times. And we have removed 54 dead columns. So in the tables that remain, things that were just clutter. And if you've seen previous talks on it, you'll appreciate how much I appreciate removing clutter. But the real question is, like, how did we do this? So the first thing is I'm very lazy, but I'm also very grumpy. Like, I am super sensitive to anything that annoys me. And I have a hard time putting up with it for long. Now, unfortunately, I am jumping into a code base that I have no understanding of with a developer who is junior, right? Like, enthusiastic, wonderful to work with, has let me tire him out straight for 4 weeks. Jonathan's been great. But, like, I can't just go in and fix all the things that I'm grumpy about. I don't really know how to do that. And there's a lot of things I'm grumpy about. So I have a checklist. And every time I see anything that annoys me, I put it on the checklist. And I tell myself that if it's on the checklist, I can be patient. Sometimes that works. And so the very first thing, database related, that made me grumpy was that the AI couldn't see the database. We would run queries, we would, like, open up the SQL manager in VS Code and run the queries and then copy the things and then put them into AI and then sort of ask it to do stuff. And like, why? Now, we're using Azure. So there's a part of me that's like, I'm already using dangerously skipped permissions. Why don't I just give it access to our database through the Azure CLI? Except for I think we all know that that story ends and our database has been deleted. And that is not what I want. So I need a way that it can see it safely. And so we built a tool. And by the way, every time I say we, what I mean is Claude. Claude did all of the actual work here. We did very, very little hand anything. The one exception of that might be the writing of the markdown files. We'll talk about that. But so we went to, well, first we went to the markdown file and said, hey, what do we want query staging to look like? And we sort of said, like, it'd be cool if it could write things, you know, like just pipe it in or read it from a file or pipe it in. We're like, yeah, that feels like enough. The important part of this is it needs to be safe. So some safety because it goes to staging. It would be more safe if I had a read-only access to staging, which we didn't have, but we could create, so we created it. And then it would be even more safe if I actually put safeguards in the code itself that told it not to run things that were dangerous. So we had it build all that. And what that means is it can go and it can say, hey, give me the stuff for meta information. It kind of comes back as this markdown formatted table. And that's knowledge. It can now get knowledge about my system. It can get structure, it can get schema, it can get performance logs, because those are also saved in SQL Server. And when I do any kind of like prototyping, it can give me reasonable stuff, right? Here's what courses should be named. Here's what instructors are. This is stuff that makes sense in the context of our world. So it has access to knowledge. But it also can do something like this, where it runs a query that doesn't work. It's surprising how often it runs queries that don't work. It's very nice not to have to get involved in that and just have it get feedback. Hey, that table doesn't exist. That row doesn't exist. That column doesn't exist. Whatever doesn't exist. So feedback is also really useful here. And then finally, if it tries to do something that's not allowed, it gets a combination of both knowledge and feedback, which I think of as guidance. It doesn't just say, like, you know, query rejected or something. Like, it actually comes back and says, hey, don't do this. Read only queries. which gives it an ability to guide. We're going to talk about this guidance a couple different places. But so we're starting to see all of these pieces come together from a very simple CLI. Probably took us somewhere in the neighborhood of 25 minutes to build this thing. We did not look at the code. Don't really see a reason to. Okay, so now we can see the database. And we start doing a little more work. And Jonathan says a thing. It was weird. I was like, it was the drop-down menu, and it has a bunch of country codes. And we needed those country codes because we were shipping them to QuickBooks. And I'm like, oh, it has a space in it. He's like, oh, yeah. I had to do a lot of work to get the interfaces to work with those spaces. And he's proud of that, right? Because this was a problem, and he solved it, right? But I am not happy with that. If you are doing any kind of gymnastics or clever things in your code to compensate for problems in your database, that's just the wrong place to fix it. You fix the database. So I want to tell him to fix the database. Except, there's a couple things that I recognize. One is, the very idea of changing the database schema freaks him out, right? Obviously you have to change the database schema from time to time, but it's one of those things where it's like, don't touch it unless you absolutely have to, something might break. And it makes sense to me, because the only way we can change the database schema is to log into production as an admin and start writing some queries. And that is also, if Claude has access to my production database, I assume it will just drop it at some point because it'll be like, oh, this is a good idea, I'll drop it and recreate, or some stupid shit like that. I'm not going to do that. I'm not going to maliciously delete my database, but I will probably accidentally delete my database. Oh, I didn't realize only that part was highlighted in the query I just ran, or yeah. So I don't want to do that either. And this is a problem that has been solved for a very long time. The implementation that I happen to like comes from Ruby on Rails. I just think it's really simple and really straightforward. And so I put this on my list, and I wait until I can get an excuse to do it. And that excuse shows up because, as I mentioned, we're really tired. I know it sounds weird. We're only going 4 hours a day. Let's just go with, I'm very intense when I'm pairing with you. Jonathan's really tired, and we had a bug that had shown up from some of the code before I was there, and fixing it. So bug fixes, right, are two things. First you have to fix the bug, and then you have to clean up the mess the bug has made, and it was not fun, and we were tired. And so on Thursday, when we get together, he is like, I'm tired, man. And I was like, you know what? I have a lot of things on my to-do list. Let's take some easy wins. Because one of the things that's nice is if you do something small, something you can do in half an hour, and it makes an improvement, it feels good. And we had just had a day and a half of, why is this bug happening? Why is this bug happening? Oh, why is this bug happening? That feels horrible. A big part of why I got into test-driven development in the first place is just I absolutely hate bugs. They are the least fun part. And for me, programming is really fun. So when programming isn't fun, that's the worst of every world I live in. And test-driven development and a lot of the refactoring and CI practices have made it so that I rarely get bugs, and when I do get bugs, they're an hour at most, right? It's not I'm not spending days on this stuff. So anyhow, I was like, let's fix this problem. To fix this problem, I need two pieces of knowledge. I need to know what is the current schema of my database? What have I done to this database so far? And then I need to know, how do I fix it? How do I update it? Both of which this pattern from Ruby solves. It solves it in a pretty basic way. The first is you just put a table in the database that tells you what version of the schema you're in. It's really simple. I don't understand why it's not everywhere. So we have a table. It literally has one row in it. It's called schema version. It has a value. And so this is both knowledge and tools. And then we have a whole bunch of update files. And so when the data, like whenever the server starts, the very first thing it does is it goes and looks at this table and says, oh, I'm on value 1. The latest value is 8. Let me run 2. Then let me run 3. Then let me run 4. And each one moves the schema forward. Right? All right. We wrote a process file for this. We'll talk about process files a lot. This is knowledge. Right? This is how do I do things here. Right? And I think in a lot of the world, probably still, but definitely, if you go back like 2 years, there was just a lot of tacit knowledge in the company. Like, oh, I've been around here a while, I know how stuff works. There's a lot of people who knew how stuff works. You never wrote that stuff down. And I was not in favor of writing it down because I found people were bad at writing it down and that nobody read it. And so why would you spend all that time doing stuff? I don't know if you've ever been in a place where like somebody important is quitting and they're like, oh, take the last week and write up everything you know. And then you show up like a week later when that person is gone and and then like that thing makes no sense at all. You're like, that person wasted a week. This is not helping me. But with process files, AI reads them and executes on them, and they actually are really, really useful. So anyhow, I don't want you to read all this, but I do want to point out it fits on a slide. It's not very big. When I see a lot of people's markdown files, if they have them, having them period is better than not. They're usually like hundreds of lines long. And that's just like, that's violating our small steps, right? And our focus. So anyhow, we do this. And then we have it create the very first schema update. This is a really boring update. It does 3 things. First, it checks the version. In this case, it checks, hey, that table, does it exist? If it does not, we're on version 0. Then it creates the table, and then it updates the version to version 1. So this is not exciting. I am a big fan of doing things that are not exciting, right? Like if there's something important out there and you go for the important thing, you are undoubtedly taking too big of a step. Start with something smaller that isn't important. Enough problems going to show up there. So we did this. And then once we did that, we did the second one. Right? We did it. We actually put it into production. We saw the table show up in production without us touching production. It was great. This one checks the version, does the update, in this case, fixes that problem with the extra space, and then sets my schema to version 2. This is great, but much more importantly to me is how we made this, which was this prompt. Please read the update database process. The country table returns a space in the abbreviation. Please fix it. A lot of our prompts look like this. They usually return in about 20 seconds to like 60 seconds is a long time on low reasoning thing. And we're on the $17 a month plan. We often will make it all the way to like 20% of quota. I think we had a day where we made it like up into the 50s. We're doing everything with AI, but we are not in any way waiting for it, or are we like churning just a ton of stuff? All right. Also, it would be nice to know that this stuff worked before we took it to production. So I would go in there and I would, so okay, I did that a little fast. Up here, I'd say begin transaction. and then in rollback transaction, and then I would run it. But this again is me like taking the thing and typing and then hitting the play button and then seeing it work, and then I have to like undo that. Like, already I'm annoyed. So we're building another tool. We built a tool called test schema updates. And this just literally lets us say test schema update 22, and it either comes back with success or the error message if it didn't work. Right? And I will say, like, this is in our agents. We have the agent run this to tell us that it works. And we never trust it. After it's done and it tells us it works, the very first thing we do is we run this. Like, did it actually work? So anyhow, now we've been doing some stuff with the database. There's this thing where it's like, if something is impossible, like let's say that you want to catch a unicorn, right? Well, unicorns don't exist, so it's not like I'm going to think about this problem very much, right? And that makes sense. It makes sense that my brain doesn't explore things that are impossible. But the problem is my brain can't tell the difference between impossible and just a little bit too much effort than what I'm willing to do. So if it's just a little bit too much effort, my brain is like, well, that's impossible. And it just doesn't explore it. And it never says, well, it is effort, but it would be worth it, right? But now that this became easier, my brain starts to look just a little bit. And so we did the schema updates on Thursday. It wasn't until Friday that my brain started to come to this question. But remember how I told you we were doing that bug and we were all tired because we had to both fix the bug and clean up the bug? Well, after doing this, my brain sort of said, wait a second. Staging is just it's a copy of production from like a little bit back. Why don't we just take the production back up and get the data out of there? Why did we try to like recreate everything? Like we're forensic detectives or whatever. So I said, Jonathan, why don't we just take the data out of the backup of production? And Jonathan said, the what? So onto my list went, we should have a backup of production. That seems like a thing we should have. It seems important. So yeah, we should make a backup of production. So we made some more tools. We made 4 tools. We made a backup production. We made a create a scheduled task. That tool, all it does is take the backup of production and put it into the Windows thing on Monday in the morning, like 3 in the morning or something. One of those times that like exists, not like 1:30 in the morning on a Sunday, which seems like a really reasonable time, except for then daylight savings come, and some days it doesn't exist, and other days it exists twice. So we put it on a time that exists. And it's just, I don't want to have to figure out how to do that manually. And then restore local and restore staging. Now restore local is interesting because up until that point, that didn't exist either. We had production and we had staging, which was also an Azure thing. We didn't have anything local. And it turns out having a local copy of the database is really, really useful. For example, when we ran this, it took 90 minutes to back up that database, but it only took 2 minutes to restore it locally, and it took another 90 minutes to restore it up to Azure again. It also was about a gig and a half. So like not crazy. That's not really too big, but it's kind of big. Anyhow, once we did that, my brain started looking at other things in the database. And I started to notice every time that we would open the SQL query thing, that there was a lot of tables. Like when it first opened, I didn't even see the tables. Jonathan would be like, this is the table we need. He'd scroll by things and go to the table. And I'd be like, thank God he knows what he's doing, right? But now I'm starting to notice them. And I noticed this. There's authorizations, authorizations backup, authorizations back. So like, that's obviously crap, right? And I started to think, like, why is that crap there? And it occurred to me, like, we just built the thing that lets us update the database. If you don't have that, then updating the database means going into the live production database and writing queries. And they're probably just as scared of doing that as me, probably with good reason. Probably there was an incident. And so they probably make a backup of it first before they do anything in case stuff goes wrong. And so I'm like, well, we can delete that stuff. And so we went to AI, and we said this, like, go through the database and our code and just make me a list of all the things that are abandoned, right? And it did. It put them into this file, and it put it sort of in like a couple groups. It was like, this shit's abandoned. Like, don't worry about it. I think this stuff probably, like, if you investigate it more, we didn't even care about the last two. I was like, just take the easy stuff. Let's do that. So after we write that, we clear, right? Because I want focus. It did a lot of work. It read a lot of my code base. 50,000 lines. I don't know how much. It also probably queried the database. That's why we wrote query staging. All of that I don't need anymore. Now I just need to clean it. So I clear my context. We clear our context probably about once every 5 to 10 minutes. We clear our context. And then I said, read the update schema and the abandoned tables. So this intermediate doc is like my interface between these two conversations, right? And all of a sudden, our backup of production took 2 minutes, and it was only 150 megabytes. So, woo, big wins. Now, you might be thinking, there wasn't enough backups in there to make the database 10 times bigger. And you're right. We were surprised by this number as well. But what we didn't pay attention to were these two tables that AI found for us, the EL, man, air, and probably a backup of that. This was like there was an actual package or something for this. But the idea was write all your errors to the database, like use the database as your logging system. They were no longer using that, and now we use Azure Logs, which pretty good logging system. So we had about more than a gigabyte of decade-old error logs that we do not use. And now they're gone, as well as all of those tables. Which means two things. There's a lot less for it to read, so it can be more focused. And there's a lot less false things for it to go down. And when I started to look at this, I said, you know, some of our pages are kind of slow. I bet it's not like they've been showing themselves to be really on top of our database. I bet they're missing some important indexes. So we wrote this prompt. Please inspect the database and code and make a list that would be helpful on the queries we run. Now this is neat, right? Because it can query our code and see like what is our schema, but it also can query our production logs to say what queries are slow, and it can query our code to say, oh yeah, this makes sense of why it would be slow. And again, we clear our context after this is done. And then we tell it, hey, implement the good ones. Right? In this case, I think we took the first 2 levels. It was top suggested and Nick suggested. So there's our interface again. Oh, I'll get to that in a second. And now stuff just works better. It's a lot faster. It takes less compute. That was like maybe 20 minutes. And then finally, last thing database related is we had to make some updates to the user profile table. And at this point, We've removed the dead code. We've added indexes. I'm aware that our database is not in the best shape, but is now, like we are now like maybe, 22. We are 21 schema updates in, right? Like we started with just removing that stupid space, but because stuff is so easy, we just kept going. And so my first thought was, I bet even though this table is needed, a lot of the columns in the table aren't. So I went and I asked it, hey, are any of these columns dead? It made me another list. We removed them. And now it's just an easier table to work with. Not to mention, our EF code is easier. Like the code base is really, really getting tied to the database now. And so anything that makes our database better makes our code base better. All right. So 3 things that we're using here. Number 1 is knowledge. We ended up making 15 markdown files. One of the very first things I did was make an internal documents directory. That directory did not exist when I showed up, and that directory is full of stuff now. We created 6 CLI tools and the update process, which I also think of as a tool. Right. And now we have feedback. AI can query, can see almost everything, and sees it without noise or with less noise. Dramatically less noise, but we still have a lot of tables that have dead columns on it. That is on my to-do list. When I get my opportunities, we will get there. And the thing about this is like the snowball effect. It started with just being annoyed that I had to type a query by hand, and then got annoyed that there was an extra space in my country codes. None of that stuff is exciting. And it's not like I knew where we were going. I'm brand new to the code base too. I have a belief that if you just start getting the things that annoy you taken away, new and more interesting problems will surface. And you'll be able to solve those. But you can't even see them because you're just overwhelmed with all the little stuff. Get that little stuff out, you will get new, more interesting problems. And that is what happened here. You're going to see that happen over and over again. So it's not like a grand mastermind plan of where we're going. It is just embracing my grumpiness and not tolerating it, being like, let's fix that. All right, so we talked about the database. Let's talk about tests. Again, I'm going to start where we ended up. So we ended up with both unit and full stack tests. We ended up with the ability to easily reproduce production bugs. We ended up with tests in CI, and we ended up with 65% test coverage. How do we get there? Step number 1. I needed to know how to run the server. It doesn't seem like it's a test per se, but it's an important thing with code. If you're doing something with code, you should be able to run it. So I asked Jonathan, how do you do that? And he's like, oh, I have notes in the README. And like right there, I'm like, no. This needs to be easier. So what we did is we built a run script. Now, this is the layout that we use, right? So we have a separate window, right? So like we do this both on Mac and on Windows. But most of our development for this has actually been on Windows. So they have this thing called virtual desktops. We have a virtual desktop that only has 3 terminal windows in it. And this is where we do most of our work. And then if we're reading something, we're usually in VS Code. And if we are committing, we're usually in GitHub Desktop, which is a very nice GUI interface that makes Git not seem like Git. Kind of reminds me of Subversion. It's great. We have a Claude 1 window. That's where we do most of all of our stuff. We also have a Claude 2 window, which is where we do sort of side quests inside. Like I don't want to pollute that focus, but maybe I need to get like a quick result or build a quick tool or something like that. Claude 2 gets used way more than we would think. And then up at top, we have a terminal window where we can do stuff. And so we create this run script, and when we do, it opens up the back end and the front end. And I am already annoyed because now I have to like rearrange those windows. So we changed it so it opened them up in tabs, which was actually pretty easy to do in Windows. You could just like specifically reference the command exe and have it open in tab. In Mac, I couldn't figure out a way to do this in terminal, but I can figure out how to do it in iTerm. So I just, my window up there is an iTerm window. Works the same way. And now I can run stuff. And already I was starting to get a little bit annoyed because I would see the stuff scroll by as it happened. So my next thing is I want to be able to run the tests. So I asked Jonathan, how do you run the test? And he said, we don't have tests. Which, this was very, very early on, but like, still I had already was expecting this one. So we had a conversation with AI about what we could use. It gave us a couple options. We chose XUnit, and we had it create the first XUnit test for us, which was like assert 1 equals 1. Always a good test to start with. And then we had it build us a build and test script. So now I can run my tests just as easily as I can start my server. And when you run it, it would come back and it would tell you, hey, it succeeded. Or at the very least, I wish it looked like that. What it actually looked like was this. So I'm annoyed again. This time, I'm more annoyed that I'm not even writing it in my notes. We're fixing this now. So we have this tool that gives us feedback, which is great. So we made another process file, a fixed warnings process file. And the fixed warnings process file works like this. It says run, build, and test. So we get that list of warnings. Pick a warning. I don't care. Just pick one. And spawn a subagent. Why a subagent? I want to keep my focus clean. Subagents are a way of controlling focus. Right? And the subagent is spawned with fix all warnings of type X. Run the build and test to make sure you actually fix them. And then commit. And when you're done with that, repeat. And so when we run this, it just starts going, and then we are kind of following it, right? Because at this point, the build and test is doing a lot of work there, right? Really, we just have the assert 1 equals 1 at this point. The real thing that we're getting there is that it compiles. We're in a statically typed language, so that's not nothing, but it's not a lot, right? And so we got our tools here, which interestingly, this is the same tool, but in one place it's giving me information, in the other place it's giving me feedback, right? And then we have focus because of our subagent. And this whole process file gives us knowledge as well. So how do I validate this? I validate this manually. But the thing is, it's pretty easy to do. I was going to show you. Okay. Ooh. Yeah, okay. I see I'm not a window problem. Let's see if this works. Okay. So let me switch here. And let me switch to fixed warnings branch. Okay. So you can see up here, fixed warning, unused private fields, right? This should fix the warning of unused private fields. I have to validate it. Hey, look, it deleted stuff that was a field and nothing else, right? It also did it in this file, same thing. This file, same thing. It looks pretty good to me. That was our validation. There's like 50 some errors. There were 50 some warnings, but there was only like 8 groups of warnings. So we had to do that like 8 times. It was really easy because they all bunched nice together. It was easy. It was good. Warnings are done. That does 2 things, by the way. A, it doesn't annoy me, which is the most important thing. But the second important thing is it's less the AI has to read. Like when those would scroll by, I would get annoyed, but it's not like I would read them and say, well, that's not really what I'm doing right now. But AI doesn't get that choice. AI has to read your whole results of your build and then be like, well, that part didn't matter. I don't want that. So we just got rid of it. Okay, so anyhow, why are we doing tests at all? The answer is because we were doing stuff in the code. Not stuff that I was hired for, but stuff that we have to do anyways. Because we had a QuickBooks bug, and QuickBooks, if you don't know, means money, and money means the business really cares. So it gets popped up the stack, and that's the thing we have to fix right away. So we wrote this test. We'll go through this a lot later, but here's the key parts of it. Here's the arrange, sets up the situation. Here's our act. This is where the bug occurred. And that last part is the validate, the assert. Except for I'm using approvals, so our assert looks like this. Here's what we expect, and very specifically, we expect the new address to be there, and here's what we're actually getting, not the new address. Also no country, because the country was a key that wasn't, or in the table, and it wasn't getting loaded because it was a foreign key thing. So it would wipe out the country and keep the old address, which was exactly our bug. It took us 8 hours to write this test, and I will talk about that in detail in the third part. However, once we wrote this, this was our prompt. Run the test. They highlight a bug. Fix it. Low reasoning Claude did that in under 3 minutes. Bug fixed. The reason that works is because it has knowledge, it has tools, and it has feedback. If you give it those 2 things, or those 3 things, it works well. We also gave it focus in small steps. So it worked fantastically on this. All right, so next. There's a lot of methods in here that are very long. So that went on my list. But it's not like I'm going to write down every long method I see, because that would be my entire day. Right? So I just said fix the long methods. So now I need a way of knowing where the long methods are. And so I wrote a tool, create code analysis. It does code analysis on it, and it creates a report of my long methods. And I thought, now I can say, go read the report and fix the long methods. I had a nice little prompt that a friend of mine in Germany, Yvette, created, and I was like, oh, I'll just use that. But as soon as I did it, I ran into this problem. How do I know that it worked? And I didn't have an answer to that. In no way did I have test coverage that was anywhere near sufficient to let me know that a refactoring would work. I could test that it compiled, but pretty much that was it. And it was working in code that I wasn't looking at, right? Like I was just annoyed when it would go by. So I paused. One of the really cool things about AI is you can use Git like you actually understand Git. So I was like, oh, all these commit messages are wrong. I should fix them. AI, fix them. And it just historically went back and fixed them. Oh shit, and I should have done this on a branch. Pretend I did this on a branch and set my header back, my main head, and it did. It rewrote history, so it looked like I was smart. It's great. Like, I could have done that before. It's not like Git changed, but there's no way I would have figured out the command line Git to do. I would have just sucked it up. So I went back in time, basically, and then I said, I need some good code coverage. So I need another tool. So I had to build me another tool, create code coverage. which when it does, spits out a code coverage report. It looks like this. It's really pretty, and you can like wiggle this stuff around and stuff. That was kind of cool. This feels like a tool for me, like feedback for me. And okay, maybe, like there's times I like to wiggle those things, but I'm not the one who needs the feedback for this. I need AI to have the feedback. And the plus side is while it creates this nice HTML thing, it also creates an XML file right alongside it. That's the thing that AI actually uses. That's where AI gets the feedback from this. And now I can go and say, create the code coverage report and give me a list of the top classes that need tests. And so it created that document for me. And I just sort of put a little checklist through it. And now I need to take tests for that. And I apologize for the very hand-wavy thing that's about to happen. But I know a guy, Steve Coe, who he's out at the Seattle Software Crafters. He's been doing a lot of experiments having AI write pinning tests. And so I called Steve up and I said, hey, can I use the skill you've been developing? And he's like, yeah, I'll give you access to repo. I was going to share the repo, but the repo is private. I can't share it with you. But with Steve's coverage, all I had to do was this. / pinning test builder for the course controller, and it would write me tests for the course controller. And I just went through the checklist until I got bored. I did it on the weekend. This part was weird because, okay, so remember I've been saying like usually about a minute, 5 minutes is like a long return time for us on Claude. But these would take like 15, 20 minutes. Like I'd hit the button, walk away, come back later, hit the button again, walk away. It didn't take a lot of hands-on time, although it did run sort of throughout the day. And I actually hit my quota at like night. I had to wait till like 4 in the morning to continue, right? However, when that was done, I was up to the 65% thing. And then I could go back and take my static analysis and actually check, did those fixes work? Turns out they did. Yay, Claude, for not messing stuff up. But there was no way I was going to commit that into production without having some way of validating. All right, so those are tests. We now have ways of reproducing our bugs. We have ways of knowing when we fix things, and when we have like safety. It's great. I need to talk about nullables because without it, this would not have happened. Okay, so this is that test I was telling you from before. This part right here is what I want to talk about, the create null. We'll just sort of bring that up. What am I doing here? What I'm doing here is effectively new member organization controller, right? I'm just constructing the object. The problem is I can't do this, right? So the first thing I want to do is sort of just encapsulate that call so I can work on the thing I need to work with, not in my test. So I'm encapsulating that new member organization in a create null. So basically the idea here is I'm just trying to make a constructor that I can use. I want that test, just that one line of that test, to not explode. So here's the problem. I don't have an empty constructor. I have a lot of things I need to pass in. It's all getting passed in by dependency injection. When I showed up, those were all interfaces, but I don't know why websites do this. Like you use interfaces for dependency injection, so you have like iController, but then you only have one controller, so you have controller, and it's like every single thing you have has an interface, but then when you click on it, it goes to the interface, and then you're like, can I change this, or am I the only one who uses this interface? Screw all that noise. So like we had Claude just look at it and delete everything that was only one interface. It was great. Anyhow, so now we have this. The basic idea is if I do this, it explodes because the constructor is like, well, don't give me a null. You have to give me something real. but I don't care about any of the things it cares about. I just want to test this little piece of it. So basically, I replace every null with a create null, right? And that means I have to go to those things and create all those create nulls, which you think is like not such a big deal, but when I go to Company Manager to create null, it has the same problem that it has like 3 parameters. So now I got to go to those 3 parameters and create nulls for those, and those 3 parameters. Anyhow, that's what the tree ended up looking like. There was like 17 nulls that I needed to do to get that stupid thing to just construct. Just construct, just to get that test to work. But once I did, I could now run a test that did nothing, which is not that great. I should mention, so that's the constructor pattern, right? Basically, you just call new and you pass a create null in for every parameter. There's also some things that are interfaces. You can't get away with just constructing them because they're interfaces. So what you have to do, so I did this like for logger, is create your own logger that basically just does nothing, right? But does nothing reasonably. And then because we're in C# and they're generics, I had to create the create null on a different class called the console logger that doesn't have it. Anyhow, C# is weird. So that's the interface pattern. You just make a null interface that basically returns reasonable defaults. Anyhow, so now I can write this test and run it and it doesn't explode, which is progress. But you can very reasonably say, so what? As did we, because just being able to construct the object, even though it blocked us for like 5 or 6 hours, is not enough. We need to be able to do something with that object. So what am I doing with this object? Like you'll notice there's create nulls everywhere in this test, right? And you'll remember that what it does is it checks this piece, which this is actually the log, right? There's a lot of logging in this project. One might argue excessive logging in this project, but there's a lot of it. So this was a good thing to like capture and validate. So here's that piece. And basically what's happening is we are creating a logger that is actually capturing what is being logged. And we have to put that inside of a QuickBooks service. And then we have to put that inside of the member organization controller. And we have to shove that whole thing so that it's wired up correctly. I don't have to wire up everything. I only need to wire up the one piece that I care about. So the way you do this is when you create your create null, you pass in a whole bunch of optional parameters. So you only have to pass in what you want. And anything that you don't pass in creates the create null. And anything that you do pass in, you use. This is how you do dependency injection in your nullables. It allows you to just very nicely take the piece you care about and get it to do the thing you actually need it to do to reproduce the situation. So all the parameters should be present, but optional. So let's talk about property-based testing. Because again, already I'm getting annoyed having to write these things. Now, it did help that we had like a little process file where we could say, look at this and look at that and like figure it out. Even to be honest, just the IntelliSense AI stuff is pretty good at most of this, but it's still annoying. So what the property-based test did, first of all, are people familiar with property-based testing? No, that's a big old no. Okay, so the basic idea of property-based testing is, as opposed to normal unit testing, which is example-based testing, where you say, given A, expect B. The problem with that is you have to know what B is, right? So if you're like, given 2 plus 1, expect it to be 3, right? But you have to know 3. Property-based testing says, let's not have to know things. Let's just test a property. So given 2 and 1, let's take 2 and add 1 to it, and then subtract 1 to it and get whatever we started with. Right. And now you can just give me lots of numbers. So, ooh, wait, out of order. Let's talk about the property-based test. Then I'll go back and talk about the splitting. Okay, so the property-based test does this. It says, reflectively give me all the classes. Then filter all the classes to just give me the classes that has null, create null. Then find me the parameters for that create null, and find me the parameters for the constructor, and every single thing that's in the constructor should also be in the create null. And the cool thing about this is its tools, its feedback, and its knowledge. The moment I put this in, my test started failing. And I could just go to AI and say, fix the tests. And any time after that it created a new null, this test would automatically do it. It's better than a process file. I have to hope that it's paying attention to the process file. I know it's going to pay attention to this. All right, hold on. So I skipped over one other thing that is important. Some of the things some of the nullables, you want to actually do something useful. And the problem is a lot of code looks like this. Like this is a lot of code, it's a lot of business logic, but it also touches the database in a whole bunch of places. And the database is the really annoying thing that I need to fake out, but it's all intermixed here. So what we would do is we would push this all together, take every database call and just extract it into a method. And then we would take all those methods and encapsulate them in the data manager. And then that data manager is where we put our reasonable nullable. And the reason we did it like this is because I could validate it. Because again, this is before I had good tests. So it's this step in particular that I want to show you the validation for. I have code intermixed. All the stuff that touches the database needs to go to the bottom in its own methods. Let's go take a look. All right. So up here, so we call AI for this, right? Because doing this by hand is just extra annoying. So we call AI, but we just have it do that step. Find everything that uses the database and extract it into its own method. So you can see here, like this DB context, that's the thing that tells us it's using the database. Hey, it's using the database, 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 it's using the database. Yay, 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 lots of database stuff. And then here at the bottom, hey, look, it all showed up here. That was something we could validate, even by eyes. And then that second step, I would just see this green chunk go away, and the only other thing that went away in the class, so these references would change, but up at the top there would be a DB context that's passed in, and that also goes away. That happens, and so I could validate without tests that it did what I wanted because I broke that process into small bite-sized steps. Made it easy for AI to do it, made it easy for me to validate it. I prefer not to have to hand validate things, but you know, that's where we started. All right. So then we shove all that in a data manager, and now we can make that nullable in a way that is actually meaningful. This is out of order. That was the property-based test. All right, so that's it. Those are what occurred in the first 80 hours of me working here. The database started to get improved, and then got improved a lot. We got backups, it got faster, it got smaller, all of the crufts started to go away. Still a lot of cruft. Lots of cruft went away. Tools, we built a ton of CLI stuff. Just the other day, I made a CLI that allows me to search for references in my code, because grep was not sufficient. right? So it's this little Roslyn parser that you can say, find me all the references of this class, or find me all the references of this class.method. And it will use a Roslyn parser to find it, because every time we were asking it to do it, it was coming up short. Internal documents. Like I said, when I showed up here, there was no, when I showed up here, there was no internal documents folder. Oh, this is a wrong project. Here. This here is our internal documents folder now. All right, so there it is closed, here it is open. Notice there are entire subdirectories of stuffs. So much of the way we do stuff, it now exists in a way that AI can find it. Because every time we hit clear, it's a brand new employee. So we need to train it really quickly on the one thing that we care about. Code. So first of all, our code base is significantly smaller. All that dead stuff that goes away, it gets more dead code, and all that stuff goes away. It's also much less complex. Most of the long methods are gone. Not all of them, but most of the long methods are gone. A lot more things are modular. A lot of things, we used to have files that would have like 25 classes in them. All of that's gone. We went through and just had it pull all classes into its own file. We have tests. And our tests actually protect us quite a lot. We have good code coverage, right? Especially like most of the part that isn't covered is the very front end where the call comes in, which most of what that does is just pull the stuff out and call the actual business logic. We have tests that I can trust. That like when I ask it to do a refactoring, if the tests fail, they tell me stuff. Just the other day, we were removing it. We're able to take a table from something like 24 columns to 1 column, which was just a foreign key, not even a primary key. We're like, oh, we can delete that whole table, which is great, except for to delete that whole table, we have to make a whole bunch of things go to another table to find the stuff. We would often be like, is this tested? And we just comment out the line, run the test, see them fail, be like, oh yeah, it is. Now we can have it do stuff. We also have puppeteer tests, which are the front end, like full stack tests. Those tests are not about regression or quality to me. Those tests are about confidence. Often before we push something to like production, if it's like a database change or something, we'll run the puppeteer test and just watch it do stuff and be like, okay, site seems to be working. We also, our response times, when something goes wrong, where it used to take us 2 days, now it's usually taking us about 2 hours. It's a stressful 2 hours, but it's much better than 2 days. And our deployments are safer and faster. Our CI parts are, like we cleaned up the stuff in CI that annoys us. We have tests that run in CI. We even have like tidy code in CI, so like it makes our code look good, but it also takes away like unused usings and stuff like that. There was a whole part where we took .NET from 8 to 10. We took all our dependencies and upgraded them to the latest. Like these are things that like nobody really cares about until they become problems, and then they're really big problems. And for us, it was like an hour. Everything in this code base now is easier to work with. Not easy yet. I'm only 80 hours in. It will get better. But much, much better, and much, much better at a rate that is so much faster than what I used, like back when I was doing production code, not just coaching. Like I would do really fast things, but nothing at this speed, not even close. Right? We wrote up a report at the end of the first 2 weeks. We're 40 hours in, and we had done 38 major things. That's an average of an hour per thing that we fixed. That's insane. Anyhow, that's my story. Thanks.